welcome to this explainer. Today, we are going to completely demystify the absolutely incredible evolution of modern warfare. We're looking at a journey that stretches all the way from fragile wooden biplanes that could barely manage a 12-second flight, right up to a digitized, totally interconnected battle space operating at supersonic speeds. It's a staggering story of human engineering, and we're going to see exactly how we got here.
So here is our battle plan for the explainer. We'll start with 1, the high-tech battlefield, move right into 2, speed, stealth, and supremacy. Then we'll cover 3, the smart weapon revolution, look at 4, integrating land and sea, and finally, we'll wrap up with 5, the next century of war. Basically, we're breaking down the fundamental pillars of combat and the true purpose behind a century of relentless innovation. Let's get into it.
Section 1, the high-tech battlefield. To really grasp where we are today, you have to set the scene at the climax of modern warfare, the Persian Gulf War. Picture this. It starts with a silent, completely invisible scan from a defense support program satellite in orbit. Suddenly, a brilliant flash erupts from the ground. An enemy missile is launched, unseen by the naked eye, but a digitized image is instantly relayed to a U.S. military ground station, and in exactly 45 seconds, a 21st-century arsenal is unleashed with stunning speed and ferocity.
Okay, let's really dive into this. General H. Norman Schwarzkopf famously called this conflict the ultimate technology war, and honestly, it's pretty easy to see why. The driving forces of battle weren't just heavy armor and artillery anymore. They were silicon and circuits. The real underlying power of modern arms suddenly existed in microprocessors, laser guiding systems, electromagnetic radar jammers, and infrared sensors. Think about that for a second. The exact same foundational technologies that were sitting in your cellular phone or a basic fax machine were radically altered to create this flexible, deadly new military force.
Now, a massive part of this new high-tech battlefield relies on literally the oldest military strategy in the book, right? Being invisible to your enemy. Modern warfare is essentially a high-stakes, deadly game of sight and blindness. And this was perfectly embodied by the F-178 stealth fighter. This thing acts like an invisible black hole. It has this angular, almost bat-like fuselage covered in radar-absorbing tiles, with angles that are painstakingly calculated to deflect radar waves. It was this exact aircraft that slipped totally undetected into Iraqi airspace to drop a 2,000-pound precision smart bomb directly through the roof of Baghdad's main communications center. Moving on to Section 2, speed, stealth, and supremacy. Now, that kind of absolute air supremacy obviously didn't happen overnight. It was built upon the timeless, absolute fundamentals of combat: speed, maneuverability, and lethality. Let's look at how we engineered our way to this ultimate technological state.
Think about these numbers for a second, because the scale is just wild. In 1903, the Wright brothers managed a 12-second, 42-mile-per-hour hop. Fast forward slightly to World War I, and you've got the French SPAD-13 biplane hitting 139 miles per hour. By World War II, the legendary P-51 Mustang was escorting bombers at nearly 450 miles per hour. Then the jet age explodes in Korea, with the F-86 Sabre pushing 700 miles per hour to totally dominate the skies. And today, we have the F-15 Eagles soaring at over Mach 2.5. That is 2.5 times the speed of sound. The sheer pace of this innovation, jumping from little wooden gliders to jet-powered supercruisers in less than a century, is absolutely staggering.
Now, what's really interesting here is how highly specialized our modern arsenal became, like a giant puzzle where every piece has a very specific job to conquer a domain of the sky. The F-14 Tomcat, that's a 2-seat powerhouse using its AWG-9 radar to track 24 targets at the exact same time. The F-15 Eagle is your pure air superiority fighter. Its engines generate so much thrust that it actually exceeds the loaded weight of the plane. It can accelerate straight up. Then you have the F-16 Falcon, which uses a fly-by-wire electrical system, giving it totally unmatched agility for multi-role attacks. And, of course, the F-170A, which trades traditional dogfighting for pure stealth and surgical strikes. Section 3, the smart weapon revolution. But here's the thing. Having the best aircraft is really only half the equation. We have to pivot from the delivery vehicles to the actual munitions themselves, because today's air supremacy relies heavily on autonomous tech that strikes from far, far beyond visual range.
So a crucial concept to grasp is the massive trade-off between smart and dumb weapons. Smart weapons are unbelievably precise, but they are vastly expensive. As one pilot noted, with a precision munition, you can literally stick it down a heater vent to take out a command post without causing collateral damage. But you can't afford to do that everywhere. Contrast that against the terrifying, cost-effective reality of a massive B-52 bomber dropping 75 500-pound dumb iron bombs over a grid. That is pure area denial. If you are in that grid, you're dead, period. To actually win, a modern military needs a strategic mix of both.
But man, the autonomy of these smart weapons, it's just unbelievable. Take the Patriot missile. It uses phased array radar to react in minutes to intercept incoming ballistic missiles. Or the Tomahawk cruise missile, which basically acts as a digital pilot. It uses downward-looking radar to match terrain maps, meaning it could be fired from Boston and theoretically threaded right through the goalposts of a football stadium in D.C. The Phoenix missile, that travels at 3,000 miles per hour over 100 nautical miles. Actually, scratch that. The most mind-bending one might be SATARM. It dispenses submunitions that literally check the weather, sensing the temperature and wind, and then upon detonation, they turn a metal disc inside out to generate a bullet midair traveling thousands of feet per second. No way, right? But it's very real.
Section 4. Integrating land and sea. Because true modern dominance isn't just about controlling the air. The real watershed moment in recent history was fusing land, sea, and air platforms together into one giant, interconnected electronic nervous system. And this brilliantly illustrates how the military takes the absolute chaos of electronic warfare and boils it down into 4 digestible beats: detect, locate, lock on, and eliminate. Take the Navy's Aegis combat system, for example. It sits out on a destroyer or cruiser and can simultaneously track and guide missiles for over 100 different targets, from wavetop level to directly overhead, automatically assigning the perfect weapon to the right threat. Or look at the Apache helicopter. The pilot literally just turns their head to look at a target, and the helmet's optics automatically aim the Hellfire missiles. It is literally science fiction brought to life. Meanwhile, on the ground, you have the M1A1 Abrams tank. We're talking about a 63-ton behemoth wrapped in depleted uranium armor that can hit 42 miles per hour. It brings hit-and-run tactics to heavy armor. Beneath the waves, you've got attack submarines. And here's a surprising fact. Submarines were actually the world's original stealth technology. They were isolating nations back in World War I, long before stealth aircraft even existed. But tying all of this together is electronic warfare. By manipulating and jamming enemy communications, you completely blind them. When you hit an enemy with integrated sea, air, and land forces that are all sharing the exact same digital map, it causes a total systemic failure. The enemy simply cannot cope with that level of coordination. Let's move to Section 5, the next century of war, and see how this all builds into the future. After a century of frantic, rapid development and hyper-specialization, where on earth is military engineering headed next? Well, it brings us to the F-22. This aircraft represents the evolution of warfare coming completely full circle. Instead of needing a massive, diverse fleet where one plane handles radar, a different one drops the bombs, and another one does the dogfighting, the F-22 merges the whole shebang. It takes the invisibility of the F-117, pulls all the weapons and fuel internally so it stays off radar, and adds supercruise, meaning it can fly at supersonic speeds without constantly burning through fuel with afterburners. It literally packs the specialized traits of a dozen different airframes back into one single multi-purpose tool. But, as we look back at this incredible timeline of innovation, it really leaves us with a profound final thought. Do high-tech weapons actually mean shorter wars and fewer lives lost? What happens when these smart technologies inevitably spread across the globe? Because at the end of the day, a gun doesn't fire without a command. Even the smartest, fastest, most autonomous weapons we've discussed still require a human decision to strike. The technology has evolved flawlessly, but the ultimate question we have to ask ourselves is, will our human wisdom and our morality evolve fast enough to match our terrifying lethal potential? Definitely something to think about.